Okay, what I'm going to do, I just started another lecture. Hopefully people watch both of them because I just don't want to risk, losing information. So anyway, so based on what I said, I was talking about, I guess I just like write it here. The other thing is frequency. That is kind of scary, just like hearing my voice again. Frequency. No wonder nobody watches the lectures. Anyway. Anyway, so we have also the concept of frequency. So, light waves are also characterized by frequency. And these two concepts that I'm going to tell you, not only you're going to use in this course, that's why, I just kind of like emphasize on I want you all to learn, because all of you hear frequency, right? Like you change the frequency of the radio, if you change, when you're changing the channel, you're changing the frequency. Or like, you hear that in different contexts. So, that's why I emphasize that. So what is frequency? I'm going to write that in blue here. That is the number of cycles or crests that pass through a stationary point in 1 second. So imagine, the example that I just gave you about the wavelength, and these distances from here to here are the same as here to here, just ignore my, if I didn't, demonstrate that well. This distance should be, the same as this is equal this. But in general, if you just consider one point here, and then say the number of waves that is going to pass through this stationary point, how many are there? We call those frequency. So in general, if you have like two different waves, you can have a wave like this. You can have a wave like this. You see? So now the wavelength, if you want to calculate that, as we said, is the distance between two adjacent crests. So this is this wave, this one has a really long wavelength. But this one, on the other hand, has much shorter wavelength. And the other thing is that frequency. So if, imagine if a wave, passing through a stationary point, and then if it's like this, the first one that I kind of like this one, this is number 1, number 2. So it's kind of like intuitive that there are like more waves passing through at this point that we define, right? It's kind of like going so fast. But if the wave is going like this, kind of like the second picture, it's like there are less waves passing through a stationary point. So are you seeing what I'm going to say, where I'm going with this? So if a wave has a long wavelength, it has much lower frequency because the number of waves that can pass through the stationary point is much less. But if it's kind of like have a really small wavelength, it has much higher frequency. And this is the next thing that I'm going to write here, and that is really important. Wavelength and frequency are inversely related. the shorter the wavelength, the higher the frequency. So for your homework assignment, because I told you all that I'm going to assign you extra credits and I don't want to break this rule, I'm going to ask you to write me some definitions. And these are the definitions. What is light? And just go to the book, I just show you kind of like that is an electromagnetic radiation, and that it's not matter, it's not matter. So whatever information that you can find from your book. And what is wavelength? What is frequency? And now I want you to write components of white light and sort them based on their wavelength and frequency. So what you wanted to do is that, so components of white light is like red, orange, yellow, green, blue, indigo, and violet, right? I want you to write those colors and then one time sort them based on increasing of wavelength or like decreasing, but just specify how you're writing them. And then one time sort them based on frequency. Is everything clear? If not, just email me. And then I talk with you about this. Okay? Thank you.